Hi there, my name is Vicky and I am a VACWorks student at Optimum Solutions. This is part 2 of the video series on reinforcement learning. In part 1, Daniel introduces the concepts behind RL, and in part 2, we will walk through an example on how to use the Deep Deterministic Policy Gradient Agent, also known as the DDPG agent, to swing up and balance a pendulum modeled in Simulink. In our example, we want a downward hanging pendulum to swing to an upright position and stay there. We will take the upright position as 0 radians and the downward hanging position as pi radians. The motor can apply any torque between -2 to 2 Newton meters. This will be our action signal from our agent, which is the control unit of our pendulum, to the environment, which is the rest of the physical system. The observations from the environment will be the sine of the pendulum angle, the cosine of the angle, and the angle derivative. This is the reward function. The calculation rewards the agent for achieving a small displacement angle to the vertical, using minimal angular velocity and effort. Now that I have introduced the example, why are we using the DDPG agent as opposed to all the other agents? If you type the doc reinforcement learning agents in the command line and click enter, you will see that the reinforcement toolbox software provides built-in agents that each have their own specific action and observation spaces. Because our observations and actions in this example is continuous, we will choose an agent that supports this. As we can see, the DDPG agent is the only one that can do this at present. Now, on to our example. Let's type this into the MATLAB command line. The actions, rewards, and dynamics have been defined using this function. The observations are set here, and we can initialize the angle to pi here. After specifying the sample time and simulation time, we can create the DDPG agent. The DDPG agent uses an actor-critic policy, so we must first create an actor and a critic. To create a critic, we must first make a deep neural network with 2 inputs and 1 output. After creating the neural network, specify the critic's options using this function, and specify the action and observation information from the environment. Then we can create the critic representation using this function. The actor is constructed similarly to the critic, except with 1 input and 1 output. Finally, to create the DDPG agent, specify the DDPG agent options using this function. Then, create the agent using this function. Now onto the training. We must first specify the training options using this function. This is where we can set the number of training episodes and their duration, display the training progress, stop the training when the agent can reach the desired state using minimal control effort, and save a copy of the agent for each episode where the cumulative reward is greater than the set amount. Then we can train our agent using the train function. On the script, change do training equal to false to true, so that the agent begins to train when the script is run, instead of loading a trained agent. Finally, we can simulate the DDPG agent in the pendulum environment here. Now all we have to do is run the script. The Simulink model should pop up along with the episode manager and the pendulum. Now, this block over here is our agent, and the rest of the model is the environment. Here is the torque action signal from the agent to the environment. The observations from the environment are here, and the reward provided at every time step is calculated here. Here we can see the episode manager, where we can track the progress of our training agent. We can also see the observations with a scope in the Simulink model. And on the top right, we can see our pendulum learning how to get to the top. After a good amount of episodes of training, which will take a few hours, our pendulum should behave like this. And that's it. Thank you for watching.